Alrighty guys, what's up? Day Daddy here today, and our topic is going to be 10 gig networking. And in this video, we're going to cover just the some general 10 gig networking stuff that you need to know. And then we'll look at my particular implementation in my home lab. And then we'll look at the physical components. I bought a lot of components over the last couple months to try to make 10 gig networking work for me. And I'll show you particular tips and tricks I learned along the way, and then that in relation to the specific physical equipment. And then finally, we'll actually test the implementation and see in a real way how this might benefit your workflow. So let's go ahead and hop in. The first question we need to ask, or anyone should ask when doing anything related to networking or your home lab, is do you really need this? Because everything that you do, everything that you try to implement, not only will waste your time or take your time, but it will also take your money. So you really got to be sure, is it really worth it? And for most people, at least 10 gig networking, it's probably not worth it. Most people probably don't do enough large file transfer or anything of that nature to really warrant the cost associated with 10 gig networking. So the first thing I would encourage everybody to do is do some cost benefit analysis, go through your workflow and look at how much time this would really save you. So for example, if you are transferring many large files a day, this will probably be applicable to you. And then also how costly is this going to be for your particular setup? Do you have a very large house? Do you have a lot of devices that would need to be on this network? So go through and calculate out how much this is actually going to cost, and then look at, is this really worth it to me to, invest some money in this versus the time it's going to save me? So that's what I would encourage everyone to do here, because 10 gig networking is very expensive, at least in my opinion. So you really got to make sure it's worth it, for you before you start dabbling here. And then kind of along that same vein, when does this really make sense? This is, my opinion again. If you regularly transfer files over 1 terabyte in size. So for example, I might do this several times a day, depending on what I'm working on or where it is. I have a storage server that I like to keep things that I don't use as regularly. So if I am going to need them, I like to transfer them over to whatever the server is that needs them, so that I can work on them. So, typically I would do this overnight, and then I would just work on it the next day. But with 10 gig networking, I might, it will cut the time down such that I can, do this and then maybe go eat lunch and come back and work on something different. So it really will speed up my workflow, and it really will benefit me. So you got to make, other use cases might be if you do a lot of heavy video editing, maybe you work in 4K, 5K, and you want to edit those on different machines, or maybe you have a central NAS that has 10 gig capabilities, or like a Plex server on that, or something of that nature. These would all be good use cases for when 10 gig networking really might be warranted. Another thing that you might consider is if maybe you're not there now, but you think that you might get there in the future. This is a good way to future-proof, because 10 gig networking is coming. It's becoming more and more affordable. So if you kind of want to get ahead of the curve, you can go ahead and put this in now, especially if you're just starting to build your home lab. This might be something that would be easier to implement now than it would be to implement later, as I found out. So, and then finally, if you just want to experiment with 10 gig networking, I think it's cool. SFP plus modules or SFP modules are interesting, and it's something different than anything I've really worked with before. So if you just want to kind of dabble in that realm, feel free, but just know it's kind of an expensive dabbling. So, all right, I think that about covers this topic. And then the next logical question is, what is that should be SFP, not SPF. That's the sunscreen. So let me pause that and fix that really quick. All right, sorry about that, guys. I got that fixed now. But what is SFP plus, or SFP in general? So this is small form factor pluggable. And just quickly go over the difference. So SFP is the small form factor pluggable. That's kind of like the Gen 1, the lower transfer speed modules. And then you have SFP Plus, which can go up to 10 gigs. And then now you have QSFP, which is basically 25 gigs and above. It can go all the way up to 100 gigs. So this is SFP Plus. This is SFP. These are the same form factor. These can go in the same, basically these modules have the exact same size and they can go in the exact same slots. Now with QSFP Plus, these are larger. These have basically 4 instead of 2 lanes. They have 4 basically. So these are, as you might guess, able to transmit a lot higher rates. So basically these SFP and SFP Plus can be used interchangeably. These will go up to maximum 4 gigs from what I've read. But typically you'll find these in the 100 megabits and then up to 1 gig speeds. And then once you get into the 10 gig, there'll be SFP Plus modules. And then really anything beyond 10 gig is going to be this QSFP modules that we're talking about here. So that is one question I had early on, and it's pretty important to understand when you're talking about 10 gig networking. So the next thing is, okay, well, now we have these SFP Plus modules, but how do we use them? So you can kind of take 2 approaches. The first, and I think probably the easiest, most convenient for a lot of people, is RJ45. So you have this back module, this SFP Plus back module, and then on the front is this Ethernet connector, basically. So you don't have to go and buy any special fiber cable. You can just continue using it with Ethernet cables as you've done in the past with traditional 1 gig Ethernet ports. So, and what you would do is you just pop this guy down, or you plug this in the SFP Plus module, and you'll see a picture of it in just a minute. But you plug it in, and then you plug this Ethernet cable in, and then you can plug this into, like, for example, this 10 gig switch here, and then that would be everything you need to make 10 gig networking work from this SFP Plus module with Ethernet. Some other considerations here. Cat6 is really kind of the recommended lower end. So you really need to use Cat6 and above. Cat6A is probably optimal from my research. However, I've had no issues with Cat6A. It says here it's rated for 1 or 10 gigabit networking. Now the caveat here is it depends on the length and cable type. So I've been using this at least in my home, and I say my home. I've been using this and I've not had any problems. Although the longest cable I've used is 10 feet. So do take this with a little bit of a grain of salt. So if you have super long runs, if you have longer runs, we'll say over 100 feet, maybe this might apply to you. Maybe you want to use Cat6A. So just do keep that in mind. Now, one thing I will say is I have tried this on Cat5e, and I've done some research. You can get near 10 gig speeds for shorter runs with Cat5e. So if you have that, in your walls of your house, it's not really easy to swap out. So do not despair. You can still get pretty good transfer speeds as long as your runs are relatively short. Again, under probably 100 feet, you can use Cat5e and get pretty much 10 gig speeds. So even if you only have Cat5e, you can still probably make this work. So I just wanted to point that out as well. Okay. Another thing to talk about here is these modules. So when you're buying the modules, you need to be careful about which ones that you buy, because basically they will be rated for different transmission speeds and different lengths. So for example, this is rated for 1 gigasecond at over 100 meters, or up to 100 meters, I should say. And it's telling you that it has an RJ45 adapter on the front. So you'll also see modules where it has multiple different denominations, so it can auto-negotiate to different things. So for example, maybe you might see 100 and then 1 and then 10. That means it could work at 100 megabits, 1 gig, 10 gig, so on. So it can auto negotiate to whatever is the maximum that the two NICs can communicate on. So another consideration here, guys, is the cost. So this is an average cost. This is basically, I took a well-known generic brand called Microtech, or sorry, not Microtech, 10 Gig Tech or 10G Tech, but they make good products, and their price is kind of in the mid range. So I selected 50 as kind of a good baseline. But each module you buy is gonna run you about $50. This is like a Cat 6 cable. I think this is like just a generic 10-foot cable, probably Amazon Basics if I remember correctly. So it's gonna run you about $7 a cable. You could also buy your own, like just a long roll, and then kind of make your own cables at whatever length. That might be cheaper, although it's not really gonna save you a whole lot here at $7 a cable. And then finally, the switches themselves are super expensive. So if you want to go with the switches that are basically have the RJ45 ports already baked in without having to use SFP plus modules, these are going to be inherently more expensive than if you were to buy a switch with SFP plus modules and then you were to buy some other solution like this. So again, more convenient, but also more expensive. And this is what I would consider to be a representative example of a smaller switch. This is the TP-Link I found on Amazon that was on sale to $270 for this particular switch. So also wanted to paint cost and keep that in mind as we go forward and the different options here. So the next is you can use SFP plus with fiber. So these are these other kind of funky looking like 2-slot connectors here. These are called LC connectors. And this is the fiber cable that goes with it. You can see it has these two different, like a sender receiver. So these are called transceivers. So it's got a sender and a receiver, I guess you could say lane. And so you pop this guy or plug this guy in, and it's going to transmit over this fiber cable. Again, same thing as we saw last time. This is going to be the speed and then the length. Those are pretty much the important things to keep in mind here. And then also these are the SPF plus ports. So this guy would be put in here, and same thing with the RJ45 adapters that we saw in the previous slide. You would stick these guys in and then plug the cable in here, and then voila, you've got a 10 gig network connection. And as you can notice here, this switch is substantially cheaper because it has SFP plus ports. These seem to be cheaper switches in general, although do keep in mind this only has 4 ports that are 10 gig capable and the other had 5. All right, now the next consideration is network cards. So for most people's desktop or server or whatever you're trying to put or whatever you're trying to install 10 gig networking on, it's likely not going to support it natively. So you're going to have to buy a PCIe card like this. This is an Intel, it's pretty basic Intel card. I forget the exact specification. We'll look at that in a subsequent part here. But basically, you've got 2 SPF plus ports, and then you pop this guy in a free PCIe slot, and then you're pretty much good to go. And that's going to run you about $30 per network card that you want to install. Another way that you could go, and this is specific to this particular part we're looking at here, is specific to Dell, but you could replace your the integrated NIC in whatever server you have. So with Dell, most of the server, at least the Dell PowerEdge R720s that I have, will come with a standard like 4-port single gig NIC. So instead of these two, it's just going to have 4 of these 1 gig NICs basically as a standard. What you can do is you can take that out and you can replace it with a NIC like this that has some SFP plus ports in it. So this would give you 10 gig capability as well. It's a little bit more expensive, but you don't have to sacrifice a PCIe slot, and you can kind of use both with the integrated NIC. One other good thing about the solution is that you can use it with, like, if you use remote management, at least on the Dell side, and I'm sure it's like this with other servers as well. But if you have it on the integrated NIC that it expects, then you can control these ports with your management software, like IPMI or like iDRAC for Dell. So, and that's pretty useful. One thing I will say about this is I was not actually able, I tried this solution first. I was not actually able to get this to work. For whatever reason, the SPF plus ports were not recognized whenever I would put modules in them. Nothing, they were not assigned an interface, and they were basically just, it looked as though they were dead. So I don't know exactly why. I tried it in several different machines, and I tried several different cards, but either way, it was the same effect. So maybe there's some setting in BIOS that I missed, or some sort of thing like that. But again, this was not a solution I was able to implement, but maybe you know better than me and you can get it to work. So you could always try to go this route. And also, if you do know why this might have been, please leave me something in the comments so that I can learn and I can understand what maybe I was doing wrong here. All right, so that's the end of that, guys. And now we're going to go through specifically what I implemented for my setup. So as I mentioned before, I have some servers that I want to connect at 10 gig speeds because I do a lot of large file transfer between them for basically my research, which is AI related. So the first thing that I would say, and I think this is a good way to start for everybody, is for most people, I showed two different switches before. You're going to want a switch actually that has both SFP plus ports and just regular 1 gig ports, because it's likely that your whole network, you don't really want it to be 10G, but you want a subset of it to be. And these switches that have SFP plus ports and then regular just regular 1 gig ports are going to be a good way for you to get kind of the best of both worlds. So the one that I used, or the switch that I actually bought, this is so I couldn't find the exact one, but that was the closest thing I actually could find. But this is the one that I bought. There we go. So let's click on that guy. Okay, it's no longer listed. Sorry, let me try to find it again. Here we go. View order details. All right, so I got this for $72. Okay, and I would show you exactly what the description was when I bought it, but that's no longer available. So what I'm going to do is I'll show you the specs just through Juniper. But this is a Juniper EX 3300 24 port Gigabit Ethernet switch, and it also has 4 SFP plus ports. So basically it looks like this. Just disregard these. It only has 24. And then it has these 4 SFP plus modules. So I got this whole thing for $72 on eBay. And you can find similar like this. If we go very back, all the way back to the beginning here, this is the same switch. And it's currently, right now, you can find it for $79.99 on eBay. So the point is, you can find switches like this cheap on eBay that fit this description. So this may not be your particular use case, but my point is you can look on eBay and you can find these switches that have varying numbers of SFP plus ports and are varying sizes for whatever your particular application is. And I think this is a very cost-effective way to go. One caveat here, guys, is this switch is old. It does take a long time to boot up. It takes a long time to change the configurations because it's just kind of slow and it's a little bit old. But it is solid. It works exactly the way that it's supposed to. And for the money, in my opinion, you can't beat it. All right. So we've addressed this. So we're at $72 pretty much. The next consideration is how are you going to make the connections? And I haven't yet talked about this particular kind, but these are what are called DAC cables. So direct attach cables. And you can get these in fiber or copper flavors, but basically rather than having the modules and the cabling as separate pieces, these are all integrated. So you have the SFP plus module and then an integrated cable. In this case, it's copper, but it connects the two modules together. And it's really that simple. So this is a 1 meter length, and that's all I really needed, since the servers and my switch are right next to each other. And then for $12, you absolutely can't beat this. It's the cheapest, and it was also the most readily integrable. And what I mean by that is there's this, we'll see in the subsequent section that there are some compatibility considerations with 10 gig networking. So this, no matter what I put it in, no matter what hardware I used it with, this always worked. So I really like that as well. And that's something you have to be careful with going forward is, are all these things compatibility? Are all these things compatible? And we'll talk about that, like I said, in a subsequent section. But this, for the money, you can't beat it. This was a great option. I love that it was plug and play. So highly recommend the DAC cables going forward. All right. The next thing is one of the servers I have. So the three of the servers are Dell PowerEdge R720s, like I said, and they've got SFP plus ports in the back because I added the network cards with them. So, but one of my servers already had 10 gig networking, basically standard on the integrated NIC. So all I needed a way to be able to plug an Ethernet cable into the back of the server and then into the switch. So basically one of these kind of generic SFP plus to RJ45 adapters was really all I needed, or modules is really all I needed. So I know I said 50 was I guess kind of a ballpark price to expect, but this one was on the lower end, and at least as far as price is concerned, but had good reviews and seemed to work for the hardware, at least the switch that I was interested in. So that's why I went ahead and bought this one, and it worked just fine. Finally, again, like I was saying, I needed some network cards to enable, basically give me 10 gig NICs I could use for my Dell servers, because that didn't come standard. So what I chose were these Intel X520-SR2, and there are some similar cards that are almost identical to this with slightly different product numbers, but in my experience, all of them work, and they're they have a wide range of compatibility with a lot of different systems and servers. So I think these are a good choice. I would recommend them. The only thing to be careful of here is Intel hardware is kind of particular about which modules it will accept, and we'll talk about that in the subsequent section. But if you're going to buy Intel hardware, you need to buy Intel programmed SFP plus modules to go with it. But as you can see, this was $29. I bought three, one for each server, and it even came with the compatible Intel SFP plus modules. Unfortunately, though, in my case, these were fiber, or these were LC, and these were not RJ45. So I ended up going the RJ45 route. Or sorry, I ended up using DAC cabling, so these were irrelevant. All right, and then finally, you're going to need some, depending on which way you go, you're either going to need fiber cables or you're going to need Ethernet cables. And for me, I just stuck with Ethernet. I really only needed one to go from the Supermicro server to the switch, and you can get basically a 5-foot cable for like $5. So these cables are pretty cheap. And like I said, you could also buy just cable, and you could make your own with, cutting it and then actually making the cable yourself if you want. All right. So that is each of the parts kind of explained, and then let's look at briefly just what this actually all cost. So the switch we talked about, so $72. The DAC cables, $12 a piece basically. We needed one SFP plus RJ45 module. That was $38, and I'll post this in the video description so you guys can get access to these links if you're interested. And then again, the Intel network adapters were $29 a piece, and then finally one Cat6 Ethernet cable. So we're looking at a grand total of about $238 to connect all 4 of the servers in my home lab together so they can transmit data between each other at 10 gig speeds. So in my opinion, that's a pretty good price for the amount of time that this will save me on a weekly basis. So the next part of this video, guys, we're going to go downstairs and I am going to go through the hardware that I bought and show you it on camera, and then talk about some of the nuances and the compatibility issues and things that I had. And then I'll show you what it looks like on the server. It's pretty simple. This between the server and the switch, and it's pretty simple. And then we'll come back up and then we'll do some testing to kind of show you in practice how much time this really might save you. I always think it makes more sense to me if I can see it in practice, how these things actually work. So I'm going to go through some of the, try to keep it a little bit shorter and sweeter this time, and just show you practically how these things kind of go together, and then some of the pitfalls and how to watch out for them from a functional perspective. So first thing I want to talk about is what are the different methodologies of data transfer, or what are the different cabling types, I guess you can use. So as we talked about earlier, there's really two, but I'm going to classify it in three. And you have your direct attach cable, which is this guy right here. So everything's integrated. The SFP Plus module is attached to, in this case, a fiber optic cable. It could be copper, just whatever you choose here. Doesn't really make that much of a difference. But this is attached, so this is not separated from the cable. So you don't have this much modularity here, but as we saw before, these are cheap, relatively speaking, because you have the module and the cable. I think this was $11. So, one of your cheapest options here. Now, the next thing is you have your fiber cable. In this case, this is pretty much the same thing that's going on inside of here, except now you can reuse the cable and it's more modular. This is the LC connector. And then if we take one of these guys off, you can see there's going to be a little nodule that sticks out, which actually delivers the light, which makes the fiber optic cable work. But nothing too complicated here. This was actually the cheapest. This was only I think like $6 for a pack, or maybe it was $6 per. I can't remember which from the last part of the video, but either way, this is a cheap option as well, at least overall. And then finally, you have the good old Ethernet cable. So this is Cat 6. If you want to go 10 gig speeds, Cat 6 is going to be kind of a minimum. I think it actually recommends Cat 6A, but I've tested it with the Cat 6 and it works just fine for the shorter runs that I have in my house. So there you go. All right, so those are the three, I guess, different cable types that you can use. And so that begs the question, all right, now what are the module types? I know we've already discussed this, but I'll show you in practice now. So this is an SPF Plus module with an LC connector. So this guy, and we'll just take a pause here and show how everything connects. I know for some people this is probably going to be super redundant, but if you've never experimented with 10 gig networking before, this probably would be helpful. So here you go. Here's the module, and then we're going to, if I can do this while I'm looking at the camera, this is just going to fit right in there, or maybe it's this side. There we go. And then we're just going to click that together, and you see it locks in place, and then we can unclick. So that's really as complicated as this stuff gets, at least as far as making the connection. Now, one thing you will want to note here with these modules is they have different lengths. Fiber is, you're going to have a lot longer lengths with fiber off the bat than you will with copper. So this is one of the smaller, I guess you could say, lengths that it's good for, and it's 300 meters. I think the standard for copper is 30 meters. So do keep that in mind. And another thing to watch out for is CSs 1 and 10 So this is basically, this could be used for 1 gig speeds or 10 gig speeds, but some of these will actually have 2.5 and 5 gig speeds, so they can auto negotiate to different speeds. So if you want that level of specificity, you may want to buy a different module. So I guess my point is, be careful when you're buying these modules, because little things matter. And we'll talk about one other thing here in just a second once I introduce the other kind of module. So the other kind of module is same thing, same considerations, but now we are looking at a RJ45. So rather than having the LC, we have an RJ45 connector, so you can use your regular Ethernet cables. These are the most convenient, but they're also the most expensive, as we saw in the last part of the video. I think the LC connectors were $20, and you can find them cheaper. And this was I think it was like $39, and it goes anywhere from $39 to like $50+. The one from FS was like $70. So anyway, point is that these are more expensive, but they're also convenient because most people have Ethernet cables laying around. They probably don't have fiber cables laying around. So another thing to consider here. Okay, now while we're talking about these modules, the last thing that's super important to consider is, if you notice, this one says Intel, and then for these guys, that says GE, and this says JU for Juniper, GE is for General, by the way, and this guy says Intel. So most of these modules, especially these FS, these red ones, these are FS from fs.com, and then obviously Intel, these are manufactured, I guess I should say programmed, for particular hardware. And if you don't have that programming, or the correct programming, sometimes these won't work. I have a situation where you'll see that the hardware is recognized. So like if you run like LSPCI, you'll see that nothing's wrong with the NIC, but the module itself is not recognized, so you're not actually going to be able to find the interface. So the interface will show up as blank. I actually ran into this problem a couple of times. So basically what that tells you is you have compatibility issues, and your module is not compatible with the hardware that you're trying to use it on. So one thing to note here is Intel is particularly bad. So that's why I'm holding up this Intel module. So if you're going to use an Intel NIC, which kind of leads us right into the next part, you really need to buy one that's programmed for Intel. Otherwise, it will not work. Again, there may be corner cases and cases where that's not the case, but do keep this in mind. This is an important consideration for these modules, and if you don't, you're going to end up, buying all the stuff, you're getting it all here, like me, and you're going to be like, well, why isn't this working? And the reason is because you bought modules that aren't compatible with your hardware. So I don't really know why. I wish it wasn't like that. It really makes things a lot more of a pain than they need to be. But unfortunately, that is the way that it is. So, and I wanted to highlight this, that a lot of these you will buy are going to be kind of for specific hardware vendors, but some like this are going to be more general. Like this is made to be kind of a general SFP plus module. And supposedly it will work with many of the main manufacturers: Intel, Broadcom, most of your major switch brands, Cisco, Juniper, Ubiquiti, what have you. So, this worked in most of the things I tried it in. It did not work with the Intel card. So it's, even though on the website it said it was going to work with Intel, it did not. So, just wanted to make you guys aware of that. This is probably the most painful consideration in all of this, is will these modules actually work with the hardware that you bought? And I've been doing this now, been working at this now for a number of months, as I've shared in the last part of this video. And eventually it was too expensive, and I kind of gave up on it because I really didn't need the complexity, and it was becoming more of a headache and money sink than it was worth. So I just pared down what I was originally going to do to a smaller subset of 10G on my network. Okay, last thing to consider So this kind of leads us right into the last part. So the NICs I was talking about. So you want to make sure that your modules have compatibility with whatever your hardware is or whatever the switches that you're using. And we'll talk about those in a sec as well, although they're kind of self-explanatory. But this is a really popular card, really cheap card, really versatile card. So this is the Intel X520-DA2. So basically just a 10 gig 2SFP plus port NIC. And it pretty much will work in anything. So one consideration here, guys, is this is an Intel card. So if you're going to buy this one, you're probably going to need to buy Intel programmed stuff. If you went with like Broadcom or some other manufacturer, you probably wouldn't need to worry about that, like maybe Mellanox. So that might be a reason to go with one of those other cards from one of those manufacturers versus Intel, because Intel seems particularly fussy about the modules, like I said. But I can say this card works. It's great. I've used it in a lot of different things. So, you know, I like it, and it's fairly cheap. So good card there. Another route I tried to go early on is, especially for the Dell servers, I tried to replace the integrated NIC, this daughter card here. So this is the Broadcom, well, this is the replacement, but it's to replace the integrated Broadcom like quad 1 gig daughter card that comes standard. So this basically just has 2 1 gig ports and then 2 SFP plus modules. And I tried to replace it, but for whatever reason, I was not able to get the SFP plus ports working. It was super weird. They wouldn't show up, and they wouldn't get an interface assignment. It was very odd. So I don't really know what was going on there. I don't know if there was like some setting in BIOS I needed to enable that I couldn't find, but I tried for way longer than I should have to try to get this to work, but I was not able to. So anyway, if you know why in the comments, please let me know. I would be really curious to understand why this didn't work. But this is another option out there for you if you want to try it. You know, I can't speak how this would work in other servers besides Dell. This is the only one that I've tried to take it out of, but most servers will come with some kind of integrated NIC that you can replace. So that might be another option to go for if you're interested. But personally, I would recommend just buying, if you have a free PCIe slot, just buy one of these guys, pop it in. It's easy, it's fast, it's cheap, and you don't have to mess with the integrated NIC. So this is the route I would go. Okay, finally, these switches. So this is a cheap switch I bought from Amazon. I'm going to return it. So most of the stuff is actually going to get returned, as I mentioned in the, or I guess pointed out that we're not going to be using a lot of this stuff. I'm showing this to you because I want, I think it helped me to make a lot of sense of all this stuff, to see it and touch it and know how it goes. So I wanted to do the same thing for y'all. But this is a 5-port, 10 gig RJ45 Ethernet switch. And it's, nothing super crazy going on here, but this, basically I'm trying to get at here is, this is something that's standard for like a 10 gig RJ45 switch. On the cheaper side, you're going to get about 5 ports, something like this. And I think this one was almost $300, or $250-ish, somewhere there. But another option might be to go with a switch that just has SFP plus modules. I couldn't find one that had 5 ports, which is what I kind of needed for this application. But if you look on eBay and maybe some on Amazon that I missed perhaps, maybe you can find one there, and those are typically cheaper. Anything with SFP plus ports is typically cheaper than if you buy a switch that already comes with 10 gig RJ45 ports. So just one thing to consider there. And then a lot of switches will have some of both. So they'll have some regular Ethernet ports, and they'll have some RJ45. That's actually what my managed switch I have on the rack has, and we'll take a look at that in just a second. But I just want to highlight, there are a lot of options as far as what switches you can buy and what you actually need. I would say that for a lot of people, probably buying something with some SFP plus ports and then something with just some regular Ethernet connectors is probably going to be the best bet, because a lot of people like me don't really need their whole network to be 10 gig, or at least I don't know why you would. You only need a couple of devices to be able to communicate over 10 gig for applications like we talked about earlier, and that's going to keep the cost way down for you, and it's going to give you what you actually need. So that's another consideration, is what switch you actually need, because every extra port that you get increases the cost significantly. So, and also, I don't know that I would recommend these guys. These had pretty bad reviews. I bought them because I was being cheap. And at the end of the day, I'm returning them because A, I don't need them, and B, I'm just not comfortable that these are going to last for very long, to be honest. So I would say in this area, if you're going to go for it, spend the money and get something that's worthwhile, because you'd really hate to be, 2 years in, past warranty, and have one of these things break on you for the amount of money that you spend. So just something to consider. All right. So that's enough about the hardware. I know it was a bit long, but I really did want to give you guys the full spiel with the hardware here. I think it makes a lot more sense, at least it did to me. And the last thing, for anybody that's new, if you're wondering, okay, what are these are weird ports, I've never seen them before. So it's actually pretty simple. You're just going to take one of these guys. It doesn't really matter if it's LC or if it's RJ45, and just put it here, or in one of these holes. And if I can see to get it in there. There we go. And then just push it in until you hear it click. And that's pretty much it. And then pop these guys down. And then you can plug in, and if I can see it, put it in, there we go. Plug in your Ethernet cable. So there you go. And then take it out, pull it out, and there you go. Same thing with the DACs. They have the same port. You're just gonna plug them in, and that's it. So, all right, guys, that officially is all I have to share with you for that. We're gonna go over to the server now, and we're going to put in the DAC cables like we talked about in the previous part of the video, and then we'll go upstairs and we'll do some testing. All right, guys, so here we are at the back of all of my servers, and we can see now the switch I was talking to you guys about earlier. So this is the Juniper EX 3300 PoE. So as I was discussing earlier, this one has 4 SFP plus ports, and then I want to say, I don't even know how many this is, 24. So this has 24 1 gig ports. But this, for most people, is going to be what you need. You're going to need something that and you can't beat it for the price. I got this used on eBay for, I don't know, like less than $100, and it gave me all the functionality I need to connect all of my servers on a at 10G speeds. So can't beat this for the money. I will say it's a bit slow and it's kind of old, but it serves its purpose and it does what it's supposed to do. And for less than $100, really have no complaints. All right, so the next thing here, guys, is talk about these DAC modules. So the DAC modules literally are super simple. Man, get out of my way. You're literally just you can unplug them super quick and pop them back in. And then, as you can see, they're hot swappable, or at least they should be. So all the lights are working still, even though I just pulled this guy directly out. So yeah, those are really simple. And then they just connect to the Intel cards I showed you earlier. So those are plugged in on each of the Dell servers down here. One thing to note is this was a generic DAC cable that I bought. It said it worked for Intel, and it actually did work for Intel. So that's why I'm saying it's kind of hit or miss what will and will not work. But overall, the DAC cables worked in whatever I put them in. So I'm actually a big fan of the DAC cables because they're cheap. It's kind of a built solution, and they work. So overall, super pleased with the way that those turned out. And then finally, for the Supermicro server I have, I used basically one of those generic RJ45 SFP Plus modules we talked about earlier, and then I just used a Cat6 cable because the server itself comes with 2 ports that are already 10 gig enabled just from the integrated NIC. So I didn't realize that at first, but that was super convenient. So all I had to do was buy one of these modules and just plug it in, and everything now works at 10G. So that's pretty much a summary, guys. It's really, once you get all the like technical nuances figured out, it's as easy as just plugging shit in, and which is what I thought it would be at first. But the compatibility stuff really made it a little bit more challenging than I originally expected. So just do keep that in mind when you're going for your own setup. But for me, this is exactly what I wanted. I just wanted all of my servers to be able to transmit data to the storage server at 10 gig speeds. So, you know, transferring large files, which I do quite frequently, will take a lot less time, or kind of, it will take that, will crunch that part of my workflow down as much as possible. So anyway guys, this is it for this part of the video. I'm gonna go upstairs now, and we're going to test all of these and make sure everything's working, and then we'll see in real terms how much this will actually speed up my workflow. We have 2 machines now that have 10 gigabit NICs, and then the rest have 1 gig. So we'll actually see, you know, hopefully the performance difference or performance gains we get after installing you know, this 10 gig networking. So what we're going to do is we're going to open a terminal, and there is a command or a tool package, I guess you could say, called iperf3. So the first thing you need to do is sudo apt install iperf3. So if you haven't done that, go ahead and pull that down. There we go. So that's one of the servers that has 10 gig networking. Second thing is we need to start one of these in server mode. So what you can do is iperf3-s, and that's going to start this guy in server mode. But before we do this, one thing we need to check, and this is just may not apply to you, but if you use a firewall, like I use UFW, but whatever you use, make sure that you add this to your firewall rules. Otherwise, you won't be able to test things this way. So for me, let's just check mine really quick, and we should see that. So I've got every port 22 enabled for SSH, port 3389 enabled for remote desktop, and then this is the port that iperf3 operates on. So just make sure you've had this added to your firewall rules on both the server and then the client machine that you're going to test with. So do be aware of that. All right, so now what we can do is we can run iperf3-s, and we're starting that as a server. So now we need to go into another machine. I'll just go ahead and open a second shell. Bring this guy over here. And this guy here. And now we're going to get into another server. So one of the servers that does not have, to get a baseline, is this guy. So this guy does not have 10 gig networking installed. And so what we can do here is we can say iperf3-c, and then the IP address of the server. So for me, that is .128.168.10.205. So basically, that's this guy's IP address. I'm just saying, hey, use this guy as the server for testing. And then the last thing is we're going to do -r, because that basically does bidirectional data transfer between the client and then also back from the server to the client. So go ahead and do that. Okay. Not iperf. So there we go. Let's fix that. All right. So it's going to go and do its thing and transfer a bunch of data. And as you can see, we got getting about 950-ish megabits a second. So here we go. Let's look at this. So the sender, so basically sending 2, we got about 939 megabits a second. And then as a receiver, we're getting about 942 megabits a second on average, and able to transfer in about 10 seconds 1.1 gigabytes of data. So all in all, pretty good, what you would expect for a 1 gig NIC. But now let's try this with the server we just put the 10 gig networking on. So that is going to be still Ubuntu, but this is going to be 4. There we go. So now, again, make sure that you have changed the firewall rules if necessary, and then we can run the same command. So iperf, not ipref, -c 192.168.10.205, and then we're going to do R for bidirectional transfer. And as we can see already, we're getting close to 10 gigabits a second, which is exactly what we would expect. And there we go. So able to transfer in about 10 seconds, send about 11 gigs, and receive about 11 gigs with the transfer rates of about 9.4-ish gigabits a second. So this is really good, or at least as good as I ever want to make it. So just wanted to do, this is pretty obvious. You would expect it to be you would expect these kind of results. But I did just want to show you concretely, that this does work, and you do get a significant performance benefit when you install 10 gig networking. The next logical question, in my opinion, is how much time does this really save you? So if you were to implement 10 gig networking, how much benefit would you really get if you were to transfer files of X size? So that's what this spreadsheet, or what this table is going to help us understand. So based on the results of the previous test, we're going to look at how many, we're going to look at it as far as if you had 1 gig networking implemented and then 10 gig networking implemented. So what this is how many gigabytes, not gigabits, but gigabytes, can you transmit per second. So for 1G, based on the prior results, it's 0.11 gigabytes a second. For 10G, it's 1.1 gigabytes a second. So, and I know that you're probably thinking, okay, yeah, dude, it's just 10 times, 10G is 10 times 1G. Well, yeah, that's certainly true. But in terms of time, if you extrapolate this out, so if we talk about a file size of 100 gigabytes or 1 terabyte, the transfer rate, or transfer time, I should say, for 1G is going to be about 9,000 seconds, and then for 10G, it's going to be 900 seconds. So in terms of actual cost to you, that's 2.5 hours for 1G, waiting for a 1 terabyte file to transfer, and then that's only 15 minutes of your time waiting for that same file to transfer with 10G. So that's why, and this is a non-trivial difference, in my opinion. This is such that, at least for my workflow, now rather than having to wait overnight or basically not getting to something in the same day, I can go to lunch and then come back and then work on a completely different project, with relative ease. So that's why I think this 1 terabyte benchmark is kind of a good threshold. So if you're transmitting a lot of files that are over this size, this will significantly benefit you. If not, then you may be better off just to stick with 1G. But either way, I wanted to paint this picture and paint it in terms of the actual cost savings that you might get out of it for files of the size I recommended in the beginning. Okay, guys, so that about wraps up this video. I really hope that you took something from it, and I will see you guys in the next one. All right, guys, brief reminder here. If you enjoyed the content, please consider giving me a like and a subscribe so I can continue to grow and produce better and better content for you. If you really enjoyed the content, you might even consider buying me a coffee, and the link for how to do that will be in the video description below. If nothing else, please just give me some feedback in the comments and let me know how I'm doing, if anything's unclear or if there are anything that I can improve on. Thank you again, guys, and have a great rest of your day. Bye-bye.